Hello everyone, welcome to this series. In this video, we'll be discussing about the testing for the stationarity in time series. And this is one of the most important concept when it comes to the time series analysis. The statistical properties of the data generating process of a certain time series do not change over the time. So when the data is getting generated in the stock market, its statistical properties do not change. But for the stock market data, normally it's not the stationary data, it's a trending data, or let's say it's a seasonal data. So we cannot consider a stock market data as a stationary data, but then there are a couple of ways to make a seasonal, or let's say a trending data as a stationary data, which we will discuss in the coming video. We should not be able to see any trend data, or let's say the seasonal patterns in the stationary time series, because if it exists, then it actually violates the stationarity assumptions. Now there is another concept called white noise process, which is a stationary data, as it does not matter when we observe it, it will always look pretty much the same at any given point of time. So what we discussed right now was the strong stationarity. Strong stationary data is almost I would say next to impossible. But then we have another concept called the weak stationarity, which we can utilize for practical uses. So weak stationarity is also called the covariance stationarity. So for a time series to be classified as a covariance or a stationary data, it must satisfy these three conditions. So first one, the mean of the series must be constant, and the second one is the variance of the series must be finite, or let's say constant, and the covariance between the period of the identical distance must be constant. So what I mean to say is, if you see over here, the mean is always constant, spread will always be constant and the finite, and last but not the least, the covariance between the period of identical distance must always be identical, or let's say the constant. Now stationarity is a desired characteristic of a time series data, because it makes the modeling and the extrapolating, also called the forecasting into the future, more feasible, because the stationary series is easier to predict than our non-stationary ones, as its statistical properties will be the same in the future as they were in the past. Now there are drawbacks of non-stationary data, because the variance can be misspecified by the model. The model can give you a wrong forecast because it will not fit properly as it's supposed to be, and then we cannot take out a good or valuable time dependent patterns from the data. Now, like I said, for a stationary, for a model always, a machine learning model always expect the data to be stationary, then only it can predict the future, or it can work on the data. If it is non-stationary, then it will not be easy for the model to work on. In this video, we will work on a couple of methods. One is ADF test, which is Augmented Dickey-Fuller test. Then we have Kwiatkowski Phillips Smith-Shin test, which is also called KPSS test. And then we will plot the autocorrelation function, which is also called PACF or ACF. So let's start with the NASDAQ data. So what I have done over here, I have taken, I'm taking the data from the NASDAQ API, because I tried to do it with Indian unemployment data, but since we do not have enough data, it's just, I think from 1990 or something we have the data, and I believe we need more data for this kind of test to check the stationarity. So I thought it's better to take it from the NASDAQ website. So we are taking the NASDAQ, and then we have seasonal data, and then we have PACF, ACF and PACF, and then we are also using ADF and KPSS, which I'll be. First, let me just run this, and then I will show you the data as well. Okay, let me show you the data that we have, unemployment rate. Now let me write the function. So this is the function, ADF test function, that we'll be using. In this, we are using the AD-Fuller function, and then once we run this, we will get these values. So in this, we have defined a function used for running the ADF test and printing out the results. So we have specified the auto lag as AIC. So while so that the number of considered lags is automatically selected based on it's called AIC, which is I don't know how it is spelled, but maybe I can write it AKAIKE information AKK information criterion. See, we could have used our own manually entered the lag, but I think let the system select of its own, because when I tried, I was getting multiple kind of errors, so I preferred not to use it, right? So when I ran it and then I run it, so now we have couple of output over here. Let's go through these one by one and then define whether the data that we used is a stationary or not. Now, based on the ADF test, it states that the null hypothesis of a time series data is non-stationary. So what does that mean? It means that the ADF function basically says that the time series data is a non-stationary data. So since we have the p-value of 0.26, which is greater than 0.05, and then the statistic value statistic value is greater than the critical value, we can say that we have no reason to reject the null hypothesis, which means that we can conclude that this series is a non-stationary data, or let's say non-stationary series. Now we have written a KPSS function. Again, it uses a KPSS function. Now here we have passed the regression argument. The value of C corresponds to the null hypothesis. Now basically the null hypothesis of the KPSS test states that the time series is stationary. So we have to check whether the null hypothesis is true or false. So with a p-value of 0.01, or let's say the greater test statistic value, we can say that which is greater than the critical value, we have some reasons to say that we can reject the null hypothesis in the favor that the series is a non-stationary data. Right, now let's work on the ACF and PACF plots. So in the ACF plot, we can see that there is a significant autocorrelations, which is like above 95%, right? Confidence interval, and then which corresponds to the selected 5% significance level that we selected over here. And then we can also see in the PACF, there is one autocorrelation at lags 1, and then we have somewhere over here at 4 as well. Right. I don't know why we have two charts over here, but generally there should not be. But anyways, if you know the reason, please comment in the comment section. So one more point that we can add to this before closing this video, that why stationarity is a desired data for the time series. This is not applicable to all the statistical models. We would want our time series data to be stationary when modeling the series using some kind of auto-regressive models, like say like AR models, ARMA, ARIMA, and so on. But then there are also models that do not benefit from stationary time series. For example, those are dependent heavily on time series decomposition, let's say the exponential smoothing methods or the Facebook Prophet. Right, so this is all for this video. Please make sure to like, share, and subscribe if you like this. Thank you so much. Have a great day.